Okay, this is chapter 6.3, Areas of Circles. And before we actually get started, I wanted to show you a little video how we find the area of a circle. The area of a circle A is equal to pi r to the second power, or pi r squared. That's how we read that, and I want to show you how they found it, and I want to show you a YouTube video of what sounds like maybe a high school or college kid telling us all about it. It's pretty cool. So this is a video inside a video, and so we'll just see how this goes.
Pi r squared gives you the area of a circle. But where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So how small must we divide a circle before we can get a perfect rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle. So, the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle, as you can see, is the same as the radius, so height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and base is equal to pi r. So now base times height becomes pi r times r. Combine the r's together and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So pi r squared can be used to calculate the area of any size circle that exists.
Okay, pretty cool. Thought you guys might like that. I enjoyed it. The activity at the beginning of your chapter 6.3 on page 254 and 253 does something similar, so you can look at that if you want. We're going to move right on to 256, the key ideas, and we've got, this is a formula, the circle. This is a formula, you need to just know it. Area equals pi r squared. R, of course, stands for the radius. And you can see from the video that that's what we use to find it. There's another formula that uses a fraction instead of pi, and you can substitute. Pi is almost the same as, it's not exactly the same as, 22 over 7. If you put 22 over 7 in on your calculator, that's 22 divided by 7. If we do that real quick, you'll see that it's about the same as pi. We can find the clear button. 22 divided by 7, 3.14285714. Okay, it's not exactly pi, but it's very close. It at least matches our 3.14, and that's important. So pi is about, we're going to continue using 3.14. You could use the fraction 22/7, or you could just use the pi button on your calculator, which is much longer. It's if I turn on my calculator, 3.1415654, and it goes on into infinity. So these are important details right here. And then we're going to just do exercise or example number 1, finding the area of a circle. So they draw a circle and it shows the radius. And of course my circles are not going to be perfect, but you just have to put up with me, of 7 centimeters. And so you find the area. You've got area equals pi r squared, which area equals pi r squared. Write this every single time, and then decide whether you want to use the formula with 22/7 or whether you want to use 3.14. This time it's nice to use 22/7 times 7 squared, which is the same as times 7 times 7. Or you could write 22/7 times 49, which is what 7 squared is. Okay? That makes sense? Now the neat thing, one of the reasons I wrote it out this way, is because the 7 and the 7 can cancel out to equal 1. And then you just have 22 times 7. And you can either do that in your head, or you can use the calculator. 22 times 7 is 154. 154. Now this makes a nice round number. It ends up being centimeters to the second power. Every time we do area, we have got to have square in our answer, squared centimeters, because area always includes squares. Okay, if we had done that with pi, we would have gotten something very similar. Let me change colors and do that. If we use area equals pi r squared equals 3.14 times 7 squared, which is equal to 3.14 times 49. And if I just go ahead and put that in a calculator, 3.14 times 49, it equals 153.86. Whereas, oh, got my pen upside down, it's not writing. Equals 153.86. And you can see that this is very close to 154. 153.86 is very similar. Not quite exactly the same. It's still centimeters to the second power, centimeters squared. So if you get an answer that's similar to what the book has, you could probably call it good, because they could be using a longer version of 3.14, 159, so on, or they could be using 22/7. We'll practice this a couple of times. You might need to rewind this video and watch it again, because there's lots of ways to think about it. All right. Find the area of a circle. Use 3.14 for pi. So they've got another circle. Got to keep drawing circles. Try to make them round. I know they get kind of oval because the tool I'm using does not make exactly round circles. And oh, this is not a radius problem, this is a diameter problem. So when we have a diameter, we have to think about what to do with that. This is a diameter of 26 inches. So we still have the area equals pi r squared for our formula. And if we have 26 inches, can we figure out what r is? Well, yeah, the radius is half of the diameter, so that would be 13 inches. So we can still use that. We can still use pi is equal to 3.14 times 13 to the second power. Remember, you have to do that first, and if you don't know that, I think it's 169, but I'm going to check it. 13 times 13 is 169. Yes, times 3.14, and this is just calculator work. It equals 530 and 66 hundredths. So 500, that's not 500. Here we go. 530 and 66 hundredths, and that's inches squared. Okay? Now, if you were to just kind of estimate this in your head, let's see, what would you do? You do 3 times 13 squared, and if you just did 10 squared, that'd be 100. 3 times 100 would be only 300. 13 is 100. 13 times 13 was 169 times 3 is 507. Still, you can't estimate that very well in your head. Books sort of ask you to estimate it, but That's not working quite as well without you using a calculator. It's hard to do in your head with 13s. So we won't worry about that. It is reasonable, though, if you just do 10 squared, which is 100, times 3 is 300. You know it's bigger than that. So 530 makes sense. If you got some answer like 5,036.6, you'd say, oh, I did something weird there. And you know, that doesn't work. It can't be 5,000. It has to be maybe 500. Anyway, we'll just keep going. You just have to keep practicing with this kind of thing. If you have a semicircle, if you have half of a circle, well, that's a circle that looks maybe like this. Oop, can't use the straight line tool. They might ask you to do this. You've got a semicircle. Of course, that's a terrible semicircle, but that's because I'm doing it freehand. And they say that the diameter is 30 feet. And this is some stage in example 3. Finding the area of a semicircle, well, you're going to find that you use the same formula, a equals pi r squared, but since it's half a circle, you divide it by 2. You divide it by 2 because it's half a circle. When it's half, you just cut it in half. You could also multiply by 1/2. Area equals 1/2 times pi r squared, and that is exactly the same thing as pi r squared divided by 2. These multiply by 1/2 or divide by 2. It's the same thing. So in this problem here, we still have to convert our diameter into a radius. The radius is half of that, so it's 15 feet. And then we use our formula. Area equals 3.14 times 15 to the second power, all divided by 2. So what I'm going to do first is do the 15 to the second power. Maybe I'll rewrite that just so you can see what happens when you rewrite it. 3.14. 15 to the second power is 225 all over 2. So then you just multiply 3.14 times 225. And you get 706.5. And that makes sense. 200 times 3 is 600, so 706.5 divided by 2. And that would equal, divided by 2, 353.25. I'm running out of room here, so I have to come up here for a second. 353.25, and again we've got feet to the second power. Okay, so this would be a final answer on that problem. And I think you can make that work, 353 and 25/100ths. So you have to do a few of those. You've got to find whole circles, you've got to find semicircles, and they give you some pretty neat things about things like, there's some pretty tough problems. They've got a yin and a yang. It's a shaded region that, and I don't think I can draw it. Oop, that's a square. Let's go for circle. They've got one that looks like this, and then it does this little thing here. And if you do it right, this little half circle matches this little half circle. And this line here, actually, let's go back, and we'll cut the circle in half, kind of, and then I'll change colors, and I want you to see that this distance, well, that doesn't quite look right. This pink distance is the same as it would be if you went all the way around the circle. So this distance is about the same as half of the circumference, and this area is about the same as this area. In fact, they should be exactly equal, and that means that this area is half of the area of the circle. So if they ask you to do that and they tell you something like the diameter of the circle, and they sometimes write the diameter like this out on the edge, it's the same as if it were through the middle. If they give you the diameter and they say it's like 10 inches, then you just have to realize that the radius is 5, and then you just find the circle. Area equals pi r squared, but since we're finding the shaded area, which happens to be this part, then it's obviously half a circle, so we divide by 2. Alright, so this is a little sloppy because I don't have the technology to make it really quick freehand. It's in your book on page 259, and you're doing a similar problem to this on number 19. This is just a slightly different problem. So we just find the area of the circle and divide it by 2. This gives us a half circle. This gives us a half circle. Okay? So 3.14, radius is 5, so that'd be 25, all divided by 2, and you just plug that all into your calculator. You have to start with the square. Order of operations tells us to square this first. So you have to come up with that 25 first. 5 times 5 is 25, then multiply it by 3.14. Get your answer, which is 78.5, and then divide it by 2, which is 39.25. So it equals 39.25, and the units, we don't know what it is. Let's, I guess we'll call it inches. So the units are squared, inches squared. Okay? Maybe let's make that circle a little bit so that it actually goes around our problem. Okay, great. Now I don't want to make this assignment any longer than I need to. If you understand what's happening so far, you're just using the formula. The formula is your friend. So keep getting it out, keep using it, keep looking at it, keep writing it down. Write it down in every problem because you need to remember it. Remember that r is the radius, and if you have a diameter, then you have to cut the diameter in half. A diameter is equal to of the radius. So there's 2 radiuses in one diameter. So if you have a diameter, just cut it in half, and you'll be able to use this formula again. And don't forget that 22/7 is also approximately equal to pi, and you can put that in if there's ever a 7 or a 22 that you would like to cancel out with. All right, keep working hard.